All right, everyone. So welcome to college mathematics version of science all in one, because 9-1, 9-2, 9-3 is going to feel a lot like you're back in science class, because what we're going to be talking about in this is dimensional analysis, or another word that I like to use, it's all about conversions, how we go from one kind of measurement to another. So right above this video, you should have saw a PDF that you could have printed out. This PDF is called conversion. It's your conversions. So what I have done is I have gone through 9-1, 9-2, 9-3, and have written down all the different conversions that exist between our English system and our metric system. I have written down any formulas that you might need to know in this section. So really, all that we're doing in here is converting, and then there are a couple formulas that you're going to be messing around with, like temperature formulas. That's really what you're going to have in the end. So a lot of this is kind of plug and chug. I'm going to show you what we're going to do on the calculator and how that's going to help you, because all conversions really is about is multiplying different fractions, which is, again, all about dimensional analysis. Conversions, dimensional analysis, they are one and the same. So real quick, I want to show you that PDF and just talk to you about it. So right at the top of your PDF, it says the metric system. And right below that, I tell you how to convert in the metric system. So if your digits that you are dealing with are all labels in the metric system, this is how you deal with it. When you want to go from a large number to a small number, that is what we're doing up here in the top, where we are going from kilometer to hectometer to decameter to a meter to a decimeter to a centimeter to a millimeter. Everything up here is going from a large number to a small number. And when you are transferring in the metric system from a large number to a small number, all you're going to do is multiply by 10 for each one of the steps that you take. So for instance, if I'm going from a kilometer to a meter, that's 1, 2, 3. So take your numbers and multiply it by 10 3 times. If you want to go from a small number, which is like the millimeter, to a large number, like your kilometer, then you're going to divide by 10 as you move across. Okay? And you'll divide by 10 for every jump that you make. So if I'm going from a millimeter to a decameter, that's 1, 2, 3, 4 jumps. So you would divide by 10 4 times. Now, all of these are meters, okay? But in the metric system, we also have grams and liters. So anywhere where you see this second M, okay, the M at the very end on the right-hand side, you can replace those with G's, which represent grams. So this would be a milligram, a centigram, a decigram. Or you could replace this M that's right here with liters. So this could be kiloliter, hectoliter, decaliter. So you know, all this works the same whether we're in grams, meters, or liters. Okay, it's all about multiplying or dividing by 10. And if you forgot what each one of these little symbols right here are for, if you scroll down to the top of the next page, the second page of the notes, you'll see right over here what millimeter, centimeter, decameter, what their little abbreviations are. Okay? And again, all these M's that are right here can be traded out for grams and liters. Then what you have down below, just talking about some other things. So right over here, you got a key of all the different abbreviations that you see over in these conversions. Okay? So when you're looking at this, all these conversions right here are within our American English system. So going from feet to inches, feet to yards, inches to yards, feet to miles. Then right here, you see feet squared to inches squared, feet squared to yards squared. Or down here, this little A represents acres. So you can go from acres to feet squared, or acres to yards squared. Okay? So you can do all sorts of different things there. Down here, you can see how acres is related to miles. So these first two guys right here are all about our English system. Okay? Down here, You also have the English system for volume and things like that. So you can see how we can get from pints to quarts, quarts to gallons, gallons to fluid ounces, and all sorts of other relationships here, like inches cubed to gallons, feet cubed to gallons, yards cubed to gallons. So again, this is all, everything on this front side, other than the very top, is all about the English system. And up here, this is the metric system. This is what they use over in Europe. Much easier to work with tens. Down here, this is our jacked up American system where we like to do things weird, like feet, inches, and stuff like that. So then on the second page, this page really focuses in on going between the two systems, going from English to metric. So you can see here how inches is related to centimeters, feet related to centimeters, yards related to a meter, miles related to a kilometer. Down here you can see the area types, so inches squared to centimeter squared, and so on and so forth. This HA, that is hectare. So you can see how 1 acre is related to what we call a hectare. Then down at the bottom, this guy, this one is just nothing but metric system, because you can see centimeters, milliliters, that's all metric. Decimeter to a centimeter cubed to liters, again, that's all metric. So this right here is just nothing but metric information. But then again, like I said, most of this page is all about going from English to metric. So down here you got teaspoons to milliliter, tablespoons to milliliters, and so on and so forth. Different ways that we got our metric or our English units here to the metric units there. Then the third page, you can see, again, the English system, how we've got ounces to pounds, pounds to a ton. And again, over here, you have the different labels and things like that you'll see. Here, you got all metric. This is nothing but metric. Centimeters to milliliters to grams, decimeter cubes to centimeter cubes to liters to kilograms. And then down at the bottom, you have the English to the metric system. Okay? And then last but not least, on the very last page, you have all the formulas that allow us to go from degrees Celsius to degrees Fahrenheit, degrees Fahrenheit to degrees Celsius, degrees Celsius to Kelvin, and Kelvin to degrees Celsius. Okay? So just kind of giving you a heads up, remember I told you this in class, that in any problem that you do in the homework, they are going to supply you with any conversions that you might need. So if the homework question is all about the metric system and all you got to do is convert in the metric system, you're going to see a diagram of just this. But it will not tell you how to multiply or divide and what to do. It will just be this little guy right in here. And, okay? In the English system, if you're converting within the English system, they're going to give you the chart that you need back here. Okay? So any conversion that you need, they're going to supply that chart for you. So you don't have to memorize any of this. Okay? And that's in the homework, in the quizzes, and the test. Again, any of these guys that you need, they're going to supply. The only thing that they will not supply to you is on the last page, the formulas. They will not supply formulas for you, so this might be something that you want to have written down on a note card. Okay? Hint, hint, wink, wink, nudge, nudge. So that's the conversion notes. I wanted to explain how those are kind of written up and where I got them from, because you can use those to answer these questions. Because in my questions that I have posed for you in here, I didn't provide the chart. So you're going to need to use probably my notes when we go through these examples. So let's talk dimensional analysis. Let's talk dimensional analysis. What dimensional analysis is, it allows you to convert from one measure to another, which is basically conversions. So, this is the ability to convert and measurements. I don't know why I put that. I don't know why the and's there. To convert measurements. Okay, that's really what we do. To perform dimensional analysis, you need to multiply by what we call a unit fraction. That's the conversions you just saw on those charts. Those are actually fractions in disguise, and I'll show you how they're fractions in disguise in just a moment. Okay? So unit fractions, again, are those two handouts that I gave you. Well, that would have been in class, but they are the notes that I had printed up there, those 4 pages of notes. Okay? That's where you get the unit fractions. Okay? And so, when you're talking about the unit fractions, oh, I see how this is all messed up and not really formatted right, but that's all right. So, when you talk about the unit fractions, okay, the unit fractions get set up so that the given unit, so the unit you're starting out with, that's the one that we want to get rid of, it will go in place of the denominator of the unit fraction. And the desired unit, what we want out, will go in the numerator. That's how the unit fraction will get set up. In the denominator goes the label we're getting rid of. In the numerator goes the label we want. I'll show you this here in just a moment. Okay, so if you don't understand that, wait until you see the example again. But again, all that's going on in this is you're multiplying by a unit fraction. And you get the unit fraction from the conversion tables. So that means, again, in the unit fraction, the label you're trying to get rid of, it goes in the bottom, in the denominator. The label you want goes in the numerator. So let's take a look at an actual example and start getting through this conversion stuff. So right here, I show you the metric system. So again, I kind of already showed you that in the notes, but again, in the metric system, if you want to go from large to small, you're moving to the right. And whenever you move to the right, you're going to multiply by 10. And every jump is a multiplication by 10. If you want to move from small to large, so this was large to small. If you want to move from small to large, again, it's all about how many jumps, and each jump represents a division of 10. Okay? So again, that's what that means. And all these M's that we talked about that are right here, they can be changed to grams or liters. Okay? So here is our first conversion. And up at the top, you can see where these guys are going to come from. Because really in 9.1, 9.2, and 9.3, they split it up into 9.1 is all about converting distances. 9.2 is all about area conversions and volume conversions. 9.3 is all about weight conversions. That's how these 3 sections work. So this is all about distance, then we'll do some 9.2 ones, which is about area and volume, and then we'll hit up some 9.3 ones, which is about weight. So in here, it says we want to convert 30 inches to feet. Okay? So when I was talking earlier about the unit fraction, this is the given unit. This is the unit we want, the desired unit. So when we talked about that fraction, I told you that this is multiplication of the unit fraction. And the unit we want to get rid of goes in the denominator. The unit we want goes in the numerator. So that's how the unit fraction should be set up. And now all you got to do is go back to your notes, find some sort of relationship between inches and feet. And if we go back to our first page, right here, you see a relationship between inches and feet. 1 foot is 12 inches. So we're going to take these numbers and we're going to put them into the spots that they go in on my fraction. Each one of these is a fraction. It could be 1 foot over 12 inches, or it could be 12 inches over 1 foot. It all depends upon what you're looking for and how that unit fraction gets set up. So our unit fraction has, come on, feet over inches. And what we just discovered is that 1 foot is equal to 12 inches. So the 1 must go with the label of feet. So in the top, that's a 1. The 12 must go with the label of inches. So in the bottom, we have 12. That's the unit fraction for this one. Okay? And now all you got to do is multiply. So if you don't know how to multiply fractions, just go to your calculator. We're taking 30, right? Yeah, 30, and we're going to multiply it by 1/12. 30 times, your fraction key is alpha y equals. And put in your fraction, 1/12. Hit enter. And there it is. 5/2. Although we really would like to know what this is as it's decimal. Decimals are going to be okay in this one. So what is 5 divided by 2? So it's 2.5 feet. Forgot what the label was. So the answer is 2.5 feet. And that's it. That's really all there is to conversions. You just find the relationship on those notes or in that table that they give you in the assignment, and you set up your fraction and do the quick multiplying. So up here you can see that it says round to 2 decimals. Since there was only 1 decimal place, that's fine. 2.5. If you really want the 2 decimal places in there, 2.50 feet. So really make sure that you watch what you're doing in here. Rounding is the big killer on in this unit. Make sure you round correctly. So down here, I want you to convert 6 feet to yards. Again, you can round to 2 decimal places. So pause the video, give it a shot. All right, so we are going from 6 feet to yards. So I need to find me a conversion about feet and yards. But before we do that, let's go ahead and set up the unit fraction. So we're going to multiply by a fraction. So the unit fraction, again, the guy we want to get rid of goes in the denominator. So we are trying to get rid of feet. That's in the denominator. The guy we want, the label we want, goes in the numerator. There's the label we want. That's in the numerator. So now let's go find that relationship between feet and yards. So again, we look at this note, this page specifically, and you can see right here, oh, here's a relationship, feet and yards. So there are 3 feet equal to 1 yard. That's all we need to make our fraction. So we know that it is 3 feet equals 1 yard. So all we got to do is fill in. The 3 goes for feet. So that's down in the denominator. The 1 goes for yards. That's in the numerator. And all you have to do is multiply. So you take 6 times 1/3. Again, 6 times alpha y equals 1/3. Enter. And there's your answer. 2. Or if you want to include the rounding of 2 decimal places, you could call it 2.00 to have your 2 decimal places there, if you wanted to. Again, that's all we're doing in 9-1. Okay? They're going to give you some sort of information, and they're going to tell you what to convert to. So find that conversion relationship, make the fraction, and do your multiplying. That's it. So here, if we look at this, we are going from a hectometer to a meter. So this is all in the metric system. Okay? So if we go back to our notes, and look at those. That's what we're talking about up here. We want to take it from a hectometer to a meter. So that means we are going from a large number to a small number. So what operations are we going to talk about? We're going to be multiplying by 10. Okay? And that's all you need to do on this. Either multiply or divide. Okay? So this one, I don't really use any multiplying of fractions. Okay? I either just write out how many times I got to multiply by 10, or I write out how many times I got to divide by 10. So again, in here, we're going from the hectometer to the meter. So how many jumps is that? Going from large to small? That is 2 jumps where we will be multiplying by 10. Because when we move to the right, we multiply by 10 for every jump. So all I have to do is take 16.3 times 10 times 10. Okay? So 16.3 times 10 is 1,630 meters. Because we are going from a hectometer, which was the 16.3, to meters. That's how we work within the metric system. All you do is multiply by 10 or divide by 10. Super easy. So go ahead, try this. I've got 2,196 millimeters. Take it to a decimeter. Pause the video, give it a shot. Okay, so if you look at this, millimeters down here at the end, and then there is the centimeter, and then there's the decimeter. So we are going from a small value to a large value. So how many jumps is that? That's 2. And whenever you move to the left, you divide by 10. So we're going to divide by 10 twice. So we're going to take 2,196, which are millimeters, and we're going to divide it by 10, and then divide it by 10. And that will tell us how many decimeters we have. So 2,196 divided by 10 is 21.96. 21.96 decimeters. And that's how we convert in the metric system. It's all about multiplying or dividing by 10. Really, really straightforward. If you're moving to the right, you are multiplying by 10. If you are moving to the left, divide by 10. So, looks like I skipped some. Wow, missing some things. It seems like. Because it looks like I jump all the way into 9.3, and that can't be right. Weird. Let me pause this, and I'll be right back. Okay, that was really weird. Got it fixed. Just some of my slides got deleted. So, still in 9.1. We haven't quite reached 9.2 yet. So right here, we have done problems where we are converting English to English. We have done problems where we're converting metric to metric. Now, I have problems where I'm converting from metric to English, or vice versa. It might be that I'm at the English and in the metric. I think my second problem down below. Yeah, here's English to metric. Again, this works the same way that we did when we were converting from an English unit to another English unit. We need those unit fractions, okay? So when we look at this, we have 776 kilometers. We want to take this into miles. So we need to find that fraction that's going to work for us. And so when we look at this, we know that we want to get rid of kilometers. So again, that unit fraction, the km has to go on the bottom. We want to go to miles. So miles is in the top. So let's go look at our notes and see if we have a relationship between miles and kilometers. And I'm willing to bet you that there is one. You just got to look. So again, this is all about English to metric. So let's find something that says English to metric. Hey, English to metric. Is there something in here about kilometers and miles? Inches, centimeters, feet, centimeters, yards, meters, miles, kilometers. Perfect. This is the fraction that we need to use. So we got 1 mile is equal to 1.6 kilometers. So we now know this. 1 mile equals 1.6 kilometers. And now we can fill in the stuff that we know. Okay? So down below goes the 1.6. And it likes to fly around on me. Up above goes the 1. So we just go into our handy-dandy calculator and we're going to multiply. If there's any rounding, most likely it should tell you what to round to. I don't know if this answer comes out nice and neat, but if there is any rounding, usually what they have you do is they round to 1 decimal place or 2 decimal places like what you saw at the beginning. So let's go to our calculator. Let's take 776 and multiply it by 1 over 1.6. So 776 times alpha y equals 1 over 1.6. Enter. And there it is. So it actually came out nice and neat. So in 776 kilometers, there are 485 miles. 485. And there we go. So right down below, I have another example for you. I want you to take that from inches to centimeters. Go ahead, pause the video, give it a shot. Okay, so you have 14 inches, and we want to convert that to centimeters. So again, if we're thinking about that unit fraction, the guy we're getting rid of is inches. It goes in the denominator. The guy we want is centimeters. It goes up top. So we go into our notes. We find a relationship between inches and centimeters, and it's going to be on that second page. Oh, look, right at the top. Inches to centimeters, centimeters to inches. So we know that 1 inch is equal to 2.54 centimeters. So that's the guy that we want to use. 1 inch is equal to 2.54 centimeters. So fill in what you know. 2.54 goes in the bottom. Sorry, no it doesn't. That goes in the top because the 2.54 is with the centimeters. My bad. 2.54 in the top. The 1 is in the bottom. So we just go to our calculator and we let it do the multiplying. We're going to take 14 times 2.54 over 1. Or in other words, just times 2.54. 14 times 2.54. Enter. And there you go. So our answer is 35.56 centimeters. Okay, depending on how it wanted you to round, you'd round accordingly. 35 point, what was it again? 56 centimeters. And again, that's really as hard as what this gets. That's what's going to happen in these other sections. Sometimes you might be changing within just metrics, so you're multiplying or dividing by 10. Sometimes you're changing from English to English, so you need a conversion. Sometimes you're changing from English to metric. And again, you need that conversion, that unit fraction, that relationship. Okay? And last but not least, what they're going to do in 9.1, and same thing in some of these other ones, is they're going to ask you to tell me, is millimeter, meter, or kilometer the best way to measure the given object. So down here, it wants to know the length of a bee. So here's how I kind of think about these pieces. A millimeter. A millimeter to me, it's really, really tiny. Tiny, tiny, tiny. Okay? Think of a millimeter as something you would measure like really small objects, like maybe a pill. You'd measure a pill kind of it could be in millimeters, or even tinier than that, like the length of a fly's wing. Something really small. Think millimeter, really, really small. To me, a meter is like a yardstick. A meter is like a yardstick. Okay? It's a little bit longer. Okay? There's more length to it. So when I think a meter, it's kind of like a yardstick. And kilometers, think in terms of miles. Kilometers are huge. Think in terms of miles. Would this be a good idea to measure in miles? So kind of relating it back to some English type standards. Like in English, a millimeter is like it's smaller than an inch, but think millimeter really, really small. The meter stick, think like a yardstick. Okay? Think like a yardstick. And then kilometers, think like miles. So if we want to talk about the length of the bee, bees are not very big. So we certainly don't want to measure it in kilometers, because if I'm measuring some bee in kilometers, Lord help us all, because we all in trouble. We being attacked by giant bees. Okay? So we ain't measuring bees in kilometers. And the same thing with the meters. If I'm measuring a bee in meters, God help us all. We're being invaded. So when we talk about the length of a bee, we want to measure that guy in millimeters, because it's small, tiny. I'll give you a moment to think about a person's height and the altitude of a plane. What would you measure it in? Millimeters, meters, or kilometers? Think about it. Give me an answer. So, a person's height. Obviously, we don't measure people in miles, so that throws out the kilometers. And usually, everybody is not very, very tiny, unless you are talking about the fetus inside a female, which would be tiny, that's when I would use millimeters. But we're not talking about a fetus inside a female. We are talking about an actual human. So, a human's height is like a yard stick. So I would measure a human in meters. Okay? The altitude of an airplane. Again, you're not really small. You're not like the height of a person. Airplanes are way up in the air, so that's got to be kilometers. And they will do this same kind of practice in all the other sections. They'll be like, hey, here's an object. What would you weigh this in? Kilograms, grams, or milligrams? Or it might be like, here is some object and you want to talk about its area. Okay? Would you measure that in like millimeters squared, meters squared, or kilometers squared? Things like that. So it's really talking about, do you use a small measurement, a medium measurement, or a large measurement? Think about those things. Okay? And that's really what's going to happen in all three of these sections. You're going to convert, or you're going to tell me what you would kind of measure it in. Sometimes, again, it's all about multiplying by 10 or dividing by 10, or multiplying by some sort of unit fraction. So let's take a look at some of those. Oh, looks like I got another conversion problem. All right, so let's talk about this guy. So one more kind of problem they're going to throw at you in 9-1, I forgot about this one, is it's going to ask you which one is taller and by how much. So we've got two mountains here. We got the K2, which is 8,611 meters. We've got Everest, which is 29,035 feet. Because these are in two different measurements, we need to do some converting. Now, if we go into our table over here, we have ways that we can convert from feet to meters. Just checking on something. So we have ways that we can convert from feet to meters. I'm just looking through some things. So obviously, when you look in here, I've got feet right here and centimeters. Okay? They want plain old meters. So that means we're going to have to do two conversions on this. Let's take all these feet and convert them into centimeters, and then from centimeters, you can convert them into meters. Or another way to do it, if you want, you can convert centimeters into meters and then use that relationship. Okay? I'll kind of show you both versions of what I've just talked about. But this is what we have to use because we want to convert feet into meters. Because if you look at the directions, it says right here, round to the nearest meter. Okay? So, what we know right now is that 1 foot equals 30.48 centimeters. So we could take the feet right here, convert it to centimeters, and then change that over into meters by multiplying or dividing by 10. So let's go ahead and do that. Let's take that approach first. Let's convert this to centimeters, and then we'll convert it into meters. Okay? So we have 29,035 feet, and we want to take that into centimeters. All right, well, looking at our unit fraction, we want to get rid of feet. So that goes on the bottom. Stuff's flying around. Oops, gotta bring it back first. So feet goes on the bottom, and we're looking for centimeters, so that goes on the top. Okay, so using our conversion, the 1 goes on the bottom because it's all about feet. The 30.48 goes on the top because that's all about centimeters. And so let's do some multiplying real quick. So we need to take 29,035 and multiply that by 30.48. 29,035 times 30.48. Let me double check, make sure that it was 30.48. Yes. Hit enter. And there's what Mount Everest is in centimeters. 986.8 centimeters. So 8,000 or 184,000. I have to go back and forth between this. 184,986.8. So I got to make a little bit of room right here. Just move my equal sign over. So our answer, 884,986.8. Let me just double check that again. I can kind of view it right here. 884,886. It scrolled down to me. 884,880 or 986.8. Cool. So it matches. So now, again, we are in centimeters over here, and we want to take it to meters. So meters, decimeters, centimeters. So we want to go this direction. Since we are moving to the left, that means we're going to divide by 10. Okay? So we're going to take that 884,000 8,986.8 and divide that by 10. And when you divide that by 10, this is how many meters Everest is. 884, 8,849.868 meters. So there's how big Everest is in meters. So now we can talk about, well, who's bigger? Who's bigger? So we can take and move this back up so we can see things because it just got moved down below. So here is K2, 8,611. Here is Everest, 8,849.868. Who's bigger? Everest. And then it wants to know by how much. So you need to take the larger number minus the smaller number and make sure that you round to the nearest meter. Take the larger number minus the smaller number and round to the nearest meter. So this guy got divided by 10 and then divided by 10 again. So again, that was the number I just talked about. And we are subtracting 8,611 from it, if I remember correctly. 8,611, perfect. So back to my calculator, hit enter, and round to the nearest meter, which will be 239 meters. 239 meters. Taller than the K2. Okay? That right there ends 9.1. And again, like I said, in some of these other ones, they're going to kind of do that to you, where you do a little bit of comparison and things like that. Nothing crazy. Follow those directions, okay? If this wanted it in feet, then we would have changed the K2 to feet. All right? The other way that you could have done this, like I said, is we could have taken this right here and converted the centimeters into meters, which means that we would have moved the decimal 2 places this direction, because that's what happens when you divide by 10. So a new conversion that you know is 1 foot is really equal to 0.3048 meters. And you could have used that as your unit fraction and jumped straight into this answer of 8,849.868 meters. Okay? So it's your call on how you want to do it. All right, so 9.2, again, like I said, 9.2 is going to be a lot like 9.1, but instead of talking distances, we're talking areas and volume. So this is where really in our formula sheet, I kind of marked this up for you, those that say area or those that say volume are going to come into play. Again, more volume right down here. Okay, so those are going to come into play now. Again, volume you see right here. Those are the ones that you want to use in 9.2. Any of them that say area or volume. Okay, so 9.2. Now that you've seen the kind of problems, all these are going to work the same way. I think I only have one problem up here. Yep. So we want to convert from meters squared to feet squared. So that's English to English. Sorry, no, that is metric to English. So find that conversion, use that unit fraction, change it up, round it to decimal places as needed. Go ahead, pause the video, give it a shot. Okay, so we have meters squared, 20 of them, and we are going to feet squared. So finding that conversion. So we go back into our notes. I need something between meters squared and feet squared. So kind of looking up above, this is all English to English, English. There's English to metric, but that's not. Here we go. Here's area, because this is all about area. Squares are all about areas. Do I got anything about meters and feet squared? Yeah, right here. So here's our conversion that we want to use. 1 foot squared is equal to 0.9, or sorry, not 0.9, 0.09 meters squared. So that's what we want to use. Again, 1 foot squared equals 0.09 meters squared. About wrote feet squared again. Meters squared. All right. So again, look at that. We want to get rid of this guy, so it goes on the bottom. We want this guy, so it goes on the top. See, it's all the same process again. And just plug in your numbers. The meter squared number is 0.09. The foot squared number is 1. So go to your calculator and take 20 times 1 over 0.09. 20 times alpha y equals 1, sorry, not a 0, 1 over 0.09. And it's messing up. So let's fix this. Go away, go away, go away. Go away and scroll down. There we go. 0.09. Now we got it. And there's our answer. And again, this says round to 2 decimal places. So your final answer will be 222.22. 222.22. I should have put that in purple. Let's undo that real quick. And let's move our equal sign over so it doesn't get smushed. So answer 222.22 rounded correctly. And that's it. There you go. Done. Okay. That's a lot of what you're going to see in 9.2. So here's another one. Go ahead. Pause the video. Give it a shot. It works the same way as the other one. And since this one is about inches cubed in gallons, that's volume. Anything that's squared is all about area. Anything that is cubed is all about volume. Kind of help you out with looking. So pause it. Give it a shot. Okay. So we got 2,079 inches cubed. We want to take this into gallons. So again, find that unit fraction where inches cubed will go on the bottom. Gallons, because that's what we want, go on the top. So let's go find that information. So inches to gallons, that's all English to English. Let's see here. So we probably need to scroll back up. Here we go, English. Inches cubed to gallons, anywhere in here, and it's all about volume? Yeah, here it is. There are 231 inches cubed to 1 gallon. So that's what we want to use there. There are 231 inches cubed to 1 gallon. So just plug in what you know. The 231 goes in the bottom. 2, 3, 1. The 1 goes in the top. So all we have to do is take 2,079 and multiply it by 1 over 231. 2,079 times alpha y equals 1 over 231. Enter. And there you go. That's how many gallons are in that many inches cubed. So we got 9 Z's gallons. Again, that's all you're doing. Just like what we did in 9.1. No different. And I don't have any examples below that. So now we jump into 9.3. You see how this kind of speeds up because you're just doing the same stuff over and over and over again. So here, this is all about weight and temperature. Okay? So they want you to convert from DG, which is decigrams, to mg, which is milligrams. Remember how we had millimeters and decimeters earlier? Again, I told you you could take that m out and change it to grams. That's all we did here. So we're going from decigrams to milligrams. All right? So go ahead, pause the video, give it a shot. This is where you'll be using some of that information that comes from the first page, because we are metric to metric. Okay, so we are decigrams, then there's centigrams, and then there's milligrams. So we are starting at decigrams, moving towards milligrams. So that's moving to the right, which is all about multiplying by 10. How many times did we shift? 2 times. So all we need to do is take 7.4 and multiply it by 10 by 10. And that's what will tell us how many milligrams we'll have. Again, because this was in decigrams. You're moving from a larger number to a smaller number. So when you multiply that by 10 2 times, you get 740. Again, metric to metric is really, really easy. All you're doing is multiplying by 10 or dividing by 10. I don't believe there's... Oh, I got another one right below. So go ahead, give this guy a shot. Change it from milligrams to grams. Pause the video. Okay, so if we look at our table, grams, then decigrams, then centigrams, not centimeters, centigrams, Mr. Armstrong, and then milligrams. So we're starting here at 0.018 milligrams, and we want to move to grams. So we're going like this. We are moving to the left. When we move to the left, that means we divide by 10. And how many times did we move to the left? 3 times. So we're going to take this number, divide by 10, divide by 10, divide by 10, and that will tell us how many grams we have. So if I divide by 10 3 times, I will have that many grams. 0.000018. Yepers. And there you go. Again, metric to metric, really easy. Multiplying by 10, dividing by 10. All right, here you're going from kilograms to pounds. So we're going from metric to English. That's where you're going to want to look at page 3 of those notes, because that's where we have the English to metric, metric to English type of conversions. So again, we have that 540 kilograms, and we want to change this into pounds. Okay? So we need to find that conversion that's going to work for us. There has to be some sort of relationship between kilograms and pounds. See if I got, and I have another example right after this. So let's jump into it. Let's go to that third page, because the third page is all about your weight. So is there a relationship with English to metric? Here's English to metric and weight. Do I have a relationship between pounds and kilograms? Absolutely. It's right here. 1 pound is equal to 0.45 kilograms. So that's going to be what we use to make our fraction. 1 pound, oops, I don't know what that is, but 1 pound is equal to 0.45 kilograms, and now we fill in. We are getting rid of kilograms, so it goes on the bottom at 0.45. We want pounds, so it goes on the top with the 1. So all we have to do is multiply. We're going to take 540 times 1 over 0.45. So 540 times my fraction, alpha, equals 1 over 0.45. And there we go. That's how many kilograms will be in it. 1,200. Or excuse me, that's how many pounds, because we were at kilograms. So in 540 kilograms, there are 1,200 pounds. Okay? Go ahead. Try this one on your own. Pause the video again. Find that conversion. Use it. So we are converting 36 ounces into grams. Again, this is English to metric. So we need to find some sort of unit fraction to help us out. Ounces will go on the bottom because that's what we're getting rid of. Grams will go on the top because that's what we want. So let's go into our notes and find something. So is there a relationship between ounces and grams? Yepers. Right there. 1 ounce equals 28 grams. 1 ounce equals 28 grams. So fill in what you know. The 1 goes down with the ounces. The 28 goes up with the grams. So really all we're doing is we're taking 36 times 28. So 36 times 28. And there's how many grams we have. So 1,008. So if I have 36 ounces, then I have 1,008 grams. Okay? And finally, in the end, we get to conversions with temperatures. So this is straight formulas. This is the last page of your notes. The last page of those notes that I provided. And I got, looks like 2 examples here. Do I do any Kelvin? Nope, I got another best. Just want to check something else. So we're almost done. So here we're going from, excuse me, degrees Celsius to degrees Fahrenheit. So if you look at that last page, I have formulas here for what you're going from to. So we're going from Celsius to Fahrenheit. That's this formula that we want to use up here. All you got to do is plug in the Celsius, let the calculator do the rest of the work for the multiplying, and you get your answer. Make sure that you round accordingly, okay? So if we go back, you are using this formula that I showed you a moment ago. Degrees Fahrenheit is equal to 9/5 degrees Celsius. I don't know why I wrote that weird looking shape. Celsius plus 32. So all you have to do is plug in the 35 to the C and let the calculator do the dancing. So 9/5 times 35 plus 32. Go to the calculator, let it do that for you. So you've got alpha, y equals 9/5, parentheses, 35 plus 32. See, that looks just like what I wrote down on the board. The way that you write it down, you can do the same thing in the calculator. All I got to do now is hit enter, and I know my answer. So 35 degrees Celsius is 95 degrees Fahrenheit. And that's what they want. See, it's just plug and chug. Plug and chug. So this is 95 degrees Fahrenheit. So down here, go ahead, pause the video, and try and convert from degrees Fahrenheit to degrees Celsius. And go. Okay, so if you go back to those notes and look at those equations, this is the one that you want to run. You want to go from, you want to find degrees Celsius, and you're going to take 5/9, parenthesis, degrees Fahrenheit minus 32. So if we plug in 5/9, parentheses, our degrees Fahrenheit was -22 minus 32. So go to your calculator, let it do all the work for you. So alpha, y equals 5/9, parenthesis, negative 22 minus 32. Close the parenthesis. Enter. And there you go. So when I am negative 22 degrees Fahrenheit, I am negative 30 degrees Celsius. So this guy right there. So we found that this guy was negative 30 degrees Celsius. Notice all these answers had labels too. Very, very important, even though I don't think in the assignment you'll have to provide labels, or in the quiz or in the actual exam because it's on the computer. But I used to do paper pencil exams, and a big thing that these kids would forget is labels. Don't forget labels because every single one of these answers had a label. Last problem, a lot like what we just saw in 9.1. So they want to know, which measure would you use for the situation? Milligrams, grams, or kilograms? Okay? When you think milligrams, think really, really light, like a feather. When you think milligrams, think really, really light, like a feather. Okay? When you think grams, think like it's a little bit heavier, something like, probably like an apple. Okay? When you think grams, think like an apple. When you think kilograms, think like pounds. Because they're closely related to that. Think about like pounds. Again, this is all about lightest to heaviest. So if I was to measure a tablespoon of salt, or to weigh, not a teaspoon, I think it's a tablespoon of salt, or to weigh an adult male, or to find the weight of a bee, which one would you use? Again, milligrams, think like a feather, really, really light. Grams, think kind of like an apple, or, like bananas and things like that. It's a little bit heavier than a grams, or than milligrams. Kilograms, think like pounds. So take a moment, pause the video, and make your guesses on these three. Okay, here are the answers. A tablespoon of salt, use grams. I know it's really light, okay, but a tablespoon, there's more substance to it than what a feather would weigh, okay? So think of a tablespoon of salt in grams. Adult male, obviously that should be all about like poundage, which is a kilogram. A bee, this is the one that's the milligram. Because the bee, if you think about out of all of these, the bee is the lightest. The bee is the lightest. The bee is like a feather because there's nothing really to it. Okay? So that's why I say the tablespoon of salt has a little bit more weight than the bee. There's a difference between those. The bee would be measured in milligrams. The table of salt would be a little bit more like grams. Okay? It's a little bit heavier, especially depending on the salt that you use. Okay? And that is 9.1 through 9.3. It's all about conversions. Okay?